understand that English is actually not too flexible. It's not very a good method. But before the machine learning, yes, this is how the human actually use to teach the machine. So now I'm going to show you how the machine understand language. Okay, now I'm going to show you how the machine learns or understand or use this kind of a statistic methods for NLP application. So sometimes you have to think, is it necessary to teach the machine English for some certain application? Okay, I'm going to show you an example later on. Okay, just look at this. Yeah, for example, you have this sentence here, a very simple sentence that you have learned in the practical. Hi, Mr. Smith, I'm going to buy some vegetables, 3 tomatoes, 3 cucumbers from the store. So let me pick up some black eyed peas as well. Okay, so if you want to teach the machine to learn this, to understand this sentence, it is very difficult because the machine we need to understand first, okay, which one is the object. Okay, so what you buy, okay, so how many tomato and how many cucumbers here. This is very challenging for the machine to understand from the linguistic methods. So what we do here in the current technology, we can just simply use the count vectorizer fit transform here. So what does it mean by the fit transform and the count vectorizer? Fit transform is a method to identify how many vocabulary inside this sentence. Yeah, so the machine will identify, okay, Mr. is one of the vocab, Smith is one of the vocab, so I'm going is 1, 1, 1. Okay, so you will actually assign the vocab here, how many vocabulary. Okay, and then this count vectorizer is a method to identify the frequency of the black eye, the frequency of the buy, the frequency of cucumbers in this sentence. So you can see that now we tabulate. We have 1 black in this sentence, 1 buy in this sentence, 1 cucumber in this sentence, 1 and 1. So we, instead of teaching the machines English, we just get the frequency. We don't teach the machines English, but we kind of using the mathematical methods for certain NLP applications. We use the frequency. So how it actually works? Okay, look at this next example. So we have 2 different sentences. Cursor is gifting a Valentine present to Zuria at Taiyuan rooftop football field. Then you have a smiling face here. Sentence 2. Zuria, who is in Tunku Abdul Rahman University of Management and Technology rooftop football field, who was presented a Valentine present by Cursor. So you have 2 different sentences here. So if I want to build an application to compare the similarity between these 2 sentences, if you use the first method, linguistic, means what? Means the machine will have to understand first. Okay, cursor is a person, is doing something. Okay, send the Valentine present. What is the Valentine present? Who is Zuria? Who is the locations? Okay, blah blah blah. Okay, then we need to understand the second sentence as well, right? Zuria in these locations. Okay, was get some present by cursor. So machine will have to understand this English. But imagine that the machine doesn't have any knowledge about English. How the machine is going to understand whether these 2 sentences are similar? How? So now I'm going to show you step by step how the machine understand these 2 sentences, whether they are similar or not, using statistical methods, mathematical methods. Okay. Okay, we want to use the method that I showed you just now, which is using this count vectorizer fit transform. Yeah, we want to find out this frequency. Instead of teaching the machine English, we can just simply get the frequency of this value. Then we compare. So how it works. Okay. So now in this case. Okay, so machine is case sensitive. Right? Machine is case sensitive here. So what we do here is we try to standardize the sentence 1 and sentence 2. What we can do here is perhaps we reduce the lowercase, become small cursor. Okay, so this one also as well, TAUMT. Right, we have a put as well, TAUMT. Okay, Zuria as well, we make it as a small j. Okay, done. Sentence 2 as well, all become lowercase. All become lowercase. Okay, so this Valentine also become lowercase. Done. So what is the next thing is perhaps we can do some abbreviations. For example, in this case, TAUMT. Yeah, maybe we can set some predefined rules. Okay, what is TAUMT? TAUMT is Tunku Abdul Rahman. So we expand this sentence. So this one becomes Tunku Abdul Rahman, blah blah blah. Okay, so next, perhaps we can remove the stop words. We can remove the stop words. Yeah. So what is stop words? Stop words are the words that bring no meanings or least significance meaning to a machine. So the more information, the more words that we have, the machines take more time and memory to process all the text here. So one of the common process in the NLP is we can remove the stop words. For example, was, is, all these are actually a stop words. So if you go to the practical form, you can actually generate a full list of the stop words from the NLTK. So NLTK itself has a full list of predefined stop words that the machine thinks this kind of words are not really important and remove for you. For in this case, is are not very important, the machine will actually remove it. Remove it. To, remove it. And remove it. Okay. Is, in, remove. Okay. This one will have and remove. Okay, was remove, remove, by remove. Okay, done. So the next thing what we can do is perhaps we can perform lemmatization. So lemmatization is a process to convert the inflected word to the original word. For example, eating. So if we perform lemmatizations, so it will convert back to the base word which is eat. So the ing will be removed, so it will return you EAT. Okay, so this is a process called lemmatizations. So from here, we can see that gifting here now become gift. Okay, so what else? So we have present here, so become ed no more. Okay, done, finished. Okay, so now pretty good. Okay, so now what we can do, continue. Perhaps we can remove the punctuations. Well, we can remove the punctuation. This symbol will be removed. This symbol will be removed. Done. Okay? Or maybe you can turn the emoji into the word become love. No problem. It depends on how we perform the pre-processing. So now, what we do here is we will use the method that I showed you just now, the fit transfer and the count vectorizer. The machine will start to analyze how many vocabulary inside these two sentences. Okay, so we have cursor. We have gift. We have Valentine. We have present. We have Zuria. We have Jinku. We have Abdul. We have Rahman. We have management. We have technology. Okay, so we have a rooftop. We have football. We have field. So the machine will treat each of the words individual, independent. Yeah. So now we will start to calculate the frequency. How many frequency? Cursor in the first sentence, we have one time. Give one time, Valentine one time, present one time, Zura one time, Tinku Abdul Rahman one time, management technology one time, one time, one time. So at the sentence two, Zuria one time, Zuria's here. Who, we have one more words called who. So we don't have it, so we have one. Tunku Abdul Rahman University College here, we have one college university, one. We have rooftop, we have football, we have field. We have Valentine. Present, we have two times, so we have present, we have two times here. We have cursor, so we don't have gift, 0. So by having these tables, we can do a lot of things. We can simply compare the value instead of understanding the meanings. We can just compare the value between this. Using one method, there are a lot of methods you can compare. So one of the common methods is known as the cosine similarity. Yeah, so cosine similarity is a very well-known method to compare two strings here. this is the equations. This is the equations where we use the value from the first sentence, multiply with the second sentence, divided by the root square of the first sentence, multiply with the second sentence here. Yeah, which means that we are going to multiply this 1 with 1. 1 multiply 1 plus the second 1 multiply 0. 1 multiply 0. The third 1 multiply 1. The fourth 1 multiply 2, and so on and so forth. Until the last letters divided by the first value here is 1 square, multiply 1 square, plus blah blah blah. So we use these mathematical models to calculate this value. And eventually, if you calculate these values here, you will get a value quite close to 1, which is about 0.9 something. Then machine will use this value to do analysis. Oh, since the value is 0.9, meaning that these two sentences are quite similar from this comparison. So do we need to so-called to teach the machine English? No need. Right? So because some applications is not necessary for the machine to understand the English. In this case, we want to compare two sentences are they the same? Comparison checking, right? So you can just simply use this max method, identify the frequency here, then you compare these two values using, for example, precise similarity, cross correlations. You can easily find out whether these two sentences are the same or not the same. That's it. This is so-called mathematics methods, statistic methods. Okay, so one is linguistic, one is math. Okay, and same goes to the current technology. Let's say now we want to build a machine to identify whether it's a spam email or not spam email. So we don't need to teach the machines from the linguistic point of view. Yeah? So we can actually build this table as well. We will pump in a lot of text. Okay, we will collect a lot of text here. So perhaps all this text here is belong to spam. And this text here, okay, is not spam. So we have two bunch of documents. Then we will extract the text. So perhaps you will see a lot of words, for example, congratulations, congrats, win, price. Okay, so hi, sir. Okay, so you will see that most of the spam email that consists of this kind of words. For those that's not spam email, they don't have this kind of word, but they have this kind of word, perhaps, hi sir. So by having this table, we can teach the machine, as long as you see this kind of words, this is spam. As long as you see this kind of words, this is not spam. That's it. Then we will put this information into the machine, let the machine to find out the relationship between this word and your spam, and this word is not spam. So the machine will just learn. Without linguistic requirement, we don't need to teach the machine, okay, learn English first, this grammar, this is the word, but no need. You just teach the machine, as long as you see this word, spam, this word is not spam. So then the machine in the future is able to recognize whether it's a spam email or not spam email based on this kind of keywords. Okay? Hopefully you get the idea about why I'm talking here. Okay. So yeah, so we have two different approaches. So one is about linguistic, one is about using statistics. Alright, but however, what is the problem with this method? Okay, so this method cannot capture the orders of the words. What does it mean by order of the words? Okay, assuming you have these two sentences here. The man bites the dog. And then you have another sentence. The dog bites the man. So you can see these two sentences are totally different. One is the man bites the dog. Another one is the dog bites the man. But if you use this method, then we will get a dog bite the man. If you use this method, it's called count method. It's actually known as the type of words of term frequency. So what we will obtain here is we will get all one. the machine will treat these two sentences similar. But in fact, they are two different in terms of semantic. Two different meanings. The man by the dog by the man are two different meanings. But if we use this term frequency method, so this is what we obtain. And the machine will treat these two sentences similar. So how to solve it? We have a lot of methods to solve it actually. In the next slide. Yeah. So we can use the pack of words. We can use the n-grams here. N-grams we actually learn two words. For example, we set bigrams. For example, the man by the dog. We set bigrams here. In the algorithm, you can actually set. So the machine actually will learn the man. Okay, the man is actually considered one token. The man followed by a byte. So the next time, machine will learn man byte. Okay, followed by the. The next one, the machine will learn byte the followed by the dot. So the machine will learn two words by two words instead of word by words here. So that is, it can capture the orders of the words. So this is one of the methods. But again, using the n-gram, the machines cannot understand the meanings. So how to solve it? Perhaps we can use word embeddings. So word embedding is a very normal technique that to convert, to represent the word using the vectors. Okay, word embedding is where we represent the words using a vector. For example, vector, we use two vectors here, we have I and J. So we can use deep learning methods, for example, the walk-to-back method. Okay, we can use a skipgrams, okay, or CBOR here, to learn a vast amount of data set, and the machine will identify, okay, so let's say we have dot. So dot having a vector of 3i plus 5j. You learn about the vector. So let's say we use the two vectors here. So but in fact the word embedding is not only two vectors. We know most of the time we use 100 vectors. So let's say dot, we have a 3i plus 5j here. And let's say dot cat, we have 2i plus 7j. So you may find out that the word, they are quite similar. They will actually put at the same area. So perhaps we have another word, it's called car. We have vehicle. So the machine actually categorize or put the words that are having a similar meanings inside one area here. So this is called word embedding. It's a well-known technique in most of the NLP applications nowadays. Yeah. So we can build the word embedding ourselves. Using this method. But again, this is overlapping. It's beyond your syllabus here, so we can actually collect the data set and then we can build the word-to-vec. We can use this method word-to-vec, actually build the word embedding. Now, so why we need to build the word embedding? So that we want the machine to know the relationship between each of the words here. Now, what is the relationship between dog and cat? What is the relationship between car and the vehicle? So in order for machines understand all these things, we need to train the machines using large amount of data set. So this thing I will use the Google to train it. Yeah, so that's over already. Right, and nowadays we have what? We have recurrent neural networks, we have a self-intelligence, we have GPU. So we have a lot of methods that actually make the machine understand, but not using linguistic method anymore, using statistical methods. Okay? So yeah, that's it for today. So I hope that you know what are the approaches for the machine to understand a language now. We have linguistic and we have statistics. Yeah? Okay, so thank you and you should have a nice day. 是啊，他是这样的。